Today's subject is stairs, and you can see that some stairs are very short. This one, for example, has only one step, and the step is quite important, and it's not a step. To start with the stair, it's important to know more about the slope of a stair. So if we have one step, there is a run and a rise, and the relationship of two of these rises and one run, if I add them up, it should be 63 centimeters. So that's the run-rise ratio, which should add up to this. But there are other rules. So the safety rule would be one run plus one rise adds up to 46. A last rule, the commodity rule, which is that one run minus one rise should add up to 13. So if you calculate around a little bit, you will see that the only run-rise ratio where all three formulas will work is 29 to 17. 17 being the rise and 29 being the run. If you respect 29 by 17, it's about a 30-degree angle. So here I am on a spiral staircase, and the particularity of the spiral staircase is that the width of the stair is changing. It's wider here, about 42, and on the other side it's 27, and all of this for about 14.5 as the height of the stair. So there's a walking line here, and on the walking line the relationship between rise and step is ideal. So here you can see that the pavement consists of rubber, and the rise here is covered with a granite plate 3 centimeters thick, so that when you are descending the stair from above, you see the edge very clearly. So yet another factor is the handrail, because it should be at least 90 centimeters high. When the drop height is larger than 12 meters, it has to be 1 meter 10. But here it could be 90. So if it's 90 here, then it's 90 here as well. And you can see that here both of these should be meeting in one point. Although when I'm taking the upper flight from this landing, it's 1 meter 10 high. It's higher than it should, because I add the height of the stair. Here, as we need 90 centimeters minimum for the handrail, the handrail here is higher than the 90 centimeters in relation to where I'm standing. And the handrail is 88 centimeters high, and the balustrade is 1 meter high. So massive handrails are rather easy to draw, but here the handrail itself should be something which is easier to grab to, as the massive concrete wall is. So you can see that this type of railing with horizontal bars is not very suited in terms of security, because children could climb up and commit suicide. So if you want to be sure that this doesn't happen, use vertical rods or a closed balustrade as this one here. Although this one doesn't have a nice handrail as this one, but it's fairly safe though. So the railing is not very safe because I could climb up on it. And then what's nice is to have here the little board which prevents things from falling down in the hole, and then they would fall on the head of people that are walking up the stair. So when we are conceiving a dogleg stair, this point here is interesting, this point as well. And we have handrail is also of interest in comparison to the landing. Let's zoom in a little bit. So we have the upper flight coming, and then we have the lower flight leaving. And now I'm seeing this flight in section. In this case, I'm seeing the landing in section as well. I might have the stairwell, which ends someplace here in between. And now I have to draw the upper flight. And you can see that this is the situation where at least the descending and the ascending stair flights arrive in one point. So this is one factor, is here the height that I need to carry the load of the people using the stair to the next support. And then I might have a height of the landing and the height of the floor here, where the stair arrives, might be differing from the one of the landing. So this creates another difficulty in stair conception. So very often, if I want to have a straight or a knuckle line, I will have a stair which looks like this, rather than having a straight line of two corresponding steps here. This would represent then ideally the knuckle line. It might be a little on the side. And I also have to take into consideration here the stairwell. Another thing I might want to take into consideration is the paving of the landing, and in how far it corresponds to the paving of the steps. So this I will be seeing from above, and vertical strips in this case might not be a bad idea after all. If I want to modify this geometric situation, I could push this flight in this direction, I could push this flight in that direction, always thinking that here I have the minimum width of at least a meter. And I could also make the landing higher than it needs to be. Or I could try to create a specific situation here at this end. For example, as to be capable of continuing this geometry, then I could push this a little in that direction to arrive at the same height for the flight than in this case. So here again I can push in correspondence to the thickness of the landing, which is in this case the floor slab. You can see that the last step of this stair is flush with the floor, which gives you better details from above and from below. So let's take a look at this from above. So from above, the stairs correspond from one side to the other. And over here, they correspond as well. So both can only be explained by different heights of the flight of the stair and of the two landings here, because otherwise this would not be possible. So here we have a perfect knuckle line. And how is this possible? It is possible because the front of this step and front of this step are not in one line, but they are pushed one towards the other. Well, this is in relation to the thickness of the landing that I'm standing on. But these three things play together as to construct the perfect staircase. So here I'm next to a rather badly designed staircase. Why is it badly designed? Because you can see that from below, here bottom up, very nervous knuckle line. And here for the landing, very nervous knuckle line. Knuckle line being this change of direction, the other change of direction, and here the eye of the staircase. Why is this so? Because we don't have enough space for the staircase. And come with me. So from above you can see that the landing is rather minimum. And if you look at the step here and there, they're in the same line. And this same line of the two steps leads to the very nervous underside of the stair. So now let's calculate the number of steps that I can take before I need a landing. Should be around 18. So let's say this is 18. Might be 17 as well, but it shouldn't be more than 18. So here I am next to a very dangerous stair. Why is it dangerous? Because it has more than 18 steps in one flight. Let's measure how the steps are. The steps are changing. So this number of flights of stairs is easily recognizable as leading to auditoriums, because we have to count in Germany 60 centimeters per 100 people in the auditorium. So there's a series of auditoriums behind, and thus we need several stairs of, I would say, 3 meters width here. Let's look at the ratio. It's around 17 to 29. So that's once again what I consider as being ideal if we don't have too much space to spend.